So this looks like number 5 starts off in exactly the same way. We've got the acceleration is proportional to the distance away from the fixed point. So if we add that to both sides and make that equal 0, here's our second order differential equation with auxiliary equation m squared 2.25 equals 0. And so m equals plus or minus 1.5i, and that gives us our general solution of a cos 1.5t plus b sine 1.5t. We'll need to differentiate that as well to find out what the velocity is, and so that's minus 1.5a cos 1.5t and plus 1.5b cos 1.5t. Whoops, that should have been a sign. And what are we told? We're told it's not t equals 0, it's t equals 2. X is equal to, what does that say? T equals 2, x equal to 1.3, is it? Yeah, that's not an easy one then, is it? So stick the 2 in there. So we've got a cos 3 plus b sine 3 equals 1.3, and the maximum displacement, so the maximum displacement is going to be, the velocity is going to equal 0, isn't it? So the maximum displacement, so putting a 2 in here, that gives us minus 1.5 a sine 3 plus 1.5 b cos 3, and that equals 0. So look, there's nothing. I mean, I suppose we could rearrange that and make that into a tan, but let's do it on the simultaneous equation solver, shall we? So that might be easiest, just using it as decimals. So for a here, I've got cos 3. For b, we've got sine 3, and that equals 1.3. How many a's here have we got? So minus 1.5 sine 3 a there, and 1.5 cos 3 there. That one equals 0. So that gives me a is equal to minus, that's not right. No, it's fine. Don't worry about that. So a is minus 1.287 and b is 0.183. So I've got, yeah, I was just a little worried I had those around the wrong way, but I think it's okay. So I've got minus 1.287 cos 1.5t plus 0.183 sine 1.5t. So there is our equation. And just continuing on, so the period, actually it doesn't say the period, does it? It says that the time between its highest and its lowest. Well, let's go for the period first of all. So the period would normally be 2 pi if this was a t, but it's a 1.5 t, and so the period is that's 4 pi over 3, that, isn't it? Therefore the time from the highest to the lowest is just half of that. You think about a normal sine graph, normally that would be 2 pi, but the distance from there to there would just be pi each time. So divide that by 2, so that's 2 pi over 3. And at the end, what do you do? Criticize the model. I think we'll just be go back to the original. The small rowing boat is up and down on the sea, so we're not taking any weather into account. We're not taking tides into account. And so just some general practical issues there for part C.